signals that are less than 4 minutes in pulse width would be poorly transmitted. Signals that are 4 minutes to hours would be efficiently transmitted. We can actually do the experiment. We do different pulse width simulations, and we see that we get that below, in the minutes time scale, they're sort of dampened out, but once you get up to the several minutes, you see it very accurately, relatively accurately reflecting the amplitude and duration that we see with the original input function. So how are we thinking about this? The general notion, as we start to think, what does it all mean, is at least it's suggesting to us that there may be more of a modular organization than we had thought about, different subsystems that do different jobs within information processing. If we look at the RAS-ERC module, it looks like this very high efficiency, high bandwidth thing that's optimized for transmitting many different types of signals. And then the idea is that perhaps receptors have different mechanisms of encoding dynamics, for example, different feedback mechanisms associated with receptors can determine what sort of duration or dynamic input it generates. But then we predict that there would also be downstream modules that would be involved in decoding the specific dynamics that were transmitted through this efficient and agnostic pipe here. Okay? So it is that this is a good way to pass signals through of many different types, but yet it still filters out and doesn't transmit what are probably stochastic, very fast things associated with sort of just random associations of molecules.